Hi there, Charger people. This is Mrs. Boyd. We're talking today about perpendicular lines and the distance between them. So the distance, or the shortest length from a point to a line, is the segment that contains that point and is perpendicular to the line. So on the diagram we have here at the top, we could put a line. Oh man, that's not a straight line at all. Well, anyways, this segment DB is the distance, shortest length, from point D to AC because it's a perpendicular distance. It crosses line AC at a right angle. So perpendicular lines are always going to be the shortest distance between a point in a line. We want to draw the segment that represents the distance from the given point to the line. Well, from B to AD, we want to draw a perpendicular line that's straight down from B to line AD. We have H to IJ here. Well, we're going to imagine that IJ continues on. And from H to IJ, we'll have a line that looks something like that at a right angle. That's awful. So sorry. And point M to KL. We're going to imagine that goes on as well. And from M to KL, oh, Lordy B. Oh my gosh. There we go. And that's a straight line. That's a perpendicular line. Draw and find the distance between each set of lines on the graph. Well, we've got two lines that are parallel. The shortest distance between those two lines, we're just going to count how many lines there are. 1, 2, 3. So the distance is 3. The same thing with the graph in the middle. We can just count the lines from left to right. 1, 2, 3, 4, 5, 6, 7. So that distance is 7. And finally, we just go, don't even cross the line, we just go 1 down, that distance is 1. So the distance between any two lines that are along coordinate grid lines, we're just going to count the lines between them. Okay, now we're going to work on finding the distance between a pair of parallel lines. But we already know that that distance has to be the perpendicular distance. So the fun part is going to be finding out what that distance is. So our first step is going to be to graph these two lines. So let's do the top one first. Y equals 2x plus 2. Our y-intercept is 2. And the slope is 2. So from that red point, we're going to go up 2 and right 1. Or we can go down 2 and right 1. And then we can connect the points here. Now, we're going to do the same thing for the bottom equation, y equals 2x minus 4. Well, the y-intercept is -4, so we're going down 4. And from there, the slope is 2, so up 2, right 1. A couple times so we can connect some points here. So those are our two lines, and we want to find the perpendicular distance between these lines. So the slope of both of these lines is 2. The perpendicular slope is the negative reciprocal. So opposite sign, we start with sign of 2. The new opposite sign is negative. Positive 2, now it's going to be negative. The reciprocal of 2 is 1/2. So the slope of our perpendicular line is going to be -1/2. I'm going to choose either of these y-intercepts to be the y-intercept for the perpendicular line that we're going to draw. I'm going to choose +2 just because it's a little bit further into our graph and might look like a graph a little bit easier. So our y-intercept is going to be 2. That means the equation of our perpendicular line is going to be y equals mx plus b, -1/2 x plus 2. So let's graph that line. The y-intercept is 2, so it's going to be right there. And the slope is -1/2. Down 1, right 2. Down 1, right 2. So that is the perpendicular line that goes between my two poorly drawn parallel lines. The next part, the next step, set the perpendicular equation equal to the second equation and solve the system. So that's exactly what we're going to do. These are both y equals something. Y equals 2x minus 4 and y equals -1/2 x plus 2. We set these equal to each other. Let's see. -1/2 x plus 2 is going to equal 2x minus 4. Now we solve for x. I'm going to add 1/2 x to each side. And that gives us 2 equals 2.5x minus 4. I usually hate decimals. Today I'm going to do it. Then we're going to add this 4 to each side. We've got 6 equals 2.5x. We divide both sides by 2.5. Sorry, I'm out of room. And now I need a calculator. We get x equals 6 divided by 2.5, and that's 2.4. So now I'm actually going to move this because I'm going to have to do some more work here because we've only got half the solution to the system. Sorry, just checking my work. So we've got x is 2.4. Now we want y. So if x is 2.4, we can say y equals 2 times 2.4 minus 4, like we've got right there. So 2.4 times 2 is 4.8. And y equals 0.8. So our coordinate point for the coordinate point that we care about in this case is going to be 2.4.8. All right. So next step. Oh, so where this point is, I guess I should tell you that, huh? That is the point right here where the yellow perpendicular line crosses that bottom orange line that we want to find the distance between. So the 2 points that we're going to care about finding the distance between are going to be this 2.4, 0.8, and 0, 2. All right. So let's scoot down just a bit here on the page. We're going to find the distance between those 2 points. Well, our 2 points that we care about are 2.4 and 0.8 and 0, 2. We use the distance formula. The distance is the square root of the difference in x's, so 2.4 minus 0 squared plus the difference in y's, 0.8 minus 2 squared. Well, 2.4 squared is, that's definitely not right. It's 5.76. And that's plus 0.8 minus 2 is -1.2. And if we square that, we get 1.44. Add those together. And the distance is the square root of 7.2. And that's the answer. As ugly as and disgusting that is, the distance between our two parallel lines, this distance right here, is the square root of 7.2. And that is really, unfortunately, as good as it gets. Let's do one more and see if I can confuse you less. We've got two new lines. We've got y equals negative x. Let's draw that. We can also think of this as y equals negative 1x. So the y-intercept is 0. So we're going to have an intercept at the origin. And then the slope's negative 1. So from here, down 1, right 1, down 1, right 1, or up 1, left 1, whichever way floats your boat. That's not the best. It's not the worst. Second line, y equals negative x plus 4, or y equals negative 1x, whichever one helps you remember what we're doing here. So the y-intercept is 4. We go up to 4, and same idea, down 1, right 1, or up 1, left 1. All right, so we connect these dots. All right, let's use this bottom green equation as our reference equation this time. The slope here, like in both equations, is negative 1. That means the slope of our new perpendicular line that's going to allow us to find the distance between these lines is going to be the opposite sign, so plus, and the reciprocal, which is still 1. The y-intercept of our reference line is 0. So that means our equation of our perpendicular line is going to be y equals x, and that's it. Now we'll set the perpendicular equation equal to the second equation in our system because they both equal y. And that'll turn into x. Sorry, my cat is really enjoying himself back there. Well, x equals negative x plus 4. That's a 4. So we add x to each side and get the x's together. And that's 2x is 4. Divide by 2, and we've got x is 2. We want to know what y is equal to, so we plug 2 back in, and y equals 2, if I use that equation right there. So our point is 2, 2. Now we want to find the distance between those 2 points, being 0, 0, this point right here, and 2, 2, that one right there, that we want to know the distance between these two perpendicular lines, or parallel lines, I'm sorry. So the distance equals the change in x, 2 minus 0 squared, plus the change in y. Simplify a bit, we get 2 squared is 4, plus 4, that's the square root of 8. So our distance between the two lines is square root of 8 units. This has a really specific process. I hope you totally get it. I hope you ask any questions if you have them, and I hope to see you soon.